Welcome back to this channel. Last video covered rapamycin because it inhibits interleukin 11 and extends healthspan and lifespan. Today, this video is going to continue with X203, a monoclonal antibody found interleukin inhibitable in recent researches. And then we are going to introduce BI 765423, another interleukin 11 inhibitor which leads to longer healthspan and/or lifespan. Instead of monoantibody, it is actually a small molecule inhibitor that specifically targets IL-11 signaling pathways. In addition, differential equation is used as analysis tool in this channel for the first time. It may open another door to understand inhibition. Let's dive in. X203, an inhibitor designed to extend lifespan. The X203 monoclonal antibody represents a significant advancement in the field of aging and longevity research. It is designed to target and inhibit interleukin 11, IL-11, a cytokine that plays a crucial role in inflammation, fibrosis, and cellular senescence. By blocking IL-11, X203 aims to mitigate the harmful effects of these processes, which are major contributors to aging and age-related diseases. Mechanism of action. While IL-11 is involved in several biological processes, including tissue repair and inflammation, chronic IL-11 signaling has been associated with pathological fibrosis and the progression of various diseases, including heart failure, liver fibrosis, and certain cancers. X203 works by binding to IL-11, preventing it from interacting with its receptor on the cell surface. This inhibition reduces the downstream signaling pathways that lead to fibrosis, inflammation, and cellular aging. Mathematically, this process can be simplified by differential equation. X203 inhibition against IL-11 is non-competitive inhibition in terms of mechanism. In non-competitive inhibition, the binding of the inhibitor to the target reduces its activity but does not affect the binding of substrate. It can be thought of as having the ability of competitive and uncompetitive inhibitors, but with no preference to either type. As a result, the extent of inhibition depends only on the concentration of the inhibitor. Vmax will decrease due to the inability for the reaction to proceed as efficiently, but Km will remain the same as the actual binding of the substrate, by definition, will still function properly. Let I equals concentration of the inhibitor X203. T equals concentration of the target IL-11. Ts equals concentration of the target substrate complex, IL-11 bound to its receptor. Ti equals concentration of the target inhibitor complex, IL-11 bound to X203. S equals concentration of the substrate, IL-11 receptor. K1, K sub -1, K sub 2 equals rate constants for the respective reactions. The differential equation for the reaction with non-competitive inhibition can be given by dTs over dt equals K sub 1 time t and time S minus K sub -1 plus K sub 2 times Ts minus K sub I times Ts and times I. And the latex code is \frac d Ts dt equals \small k underscore 1 t s k underscore dash 1 plus k underscore 2 Ts k underscore I Ts I. And for the target inhibitor complex, dI over dt equals K sub I times T and times K sub -I times Ti. And the latex code is \frac d Ti dt equals \small k underscore I T I K underscore I Ti. Here, K sub I is the rate constant for inhibitor binding, and K sub -I is the dissociation constant of the target inhibitor complex. Healthspan and lifespan extension. Recent preclinical studies have shown that inhibiting IL-11 can significantly extend healthspan, the period of life spent in good health, and even lifespan. In animal models, blocking IL-11 with X203 led to improved metabolic function, enhanced muscle strength, and a reduction in age-related diseases. The therapy was also found to reduce the accumulation of senescent cells, which are cells that have stopped dividing and contribute to aging in chronic diseases. BI 765423, a small molecule inhibitor targeting IL-11 signaling pathways. When discussing inhibitors like X203 and BI 765423, it's important to understand their mechanisms and classifications. Here's how they fit into common types of inhibition. X203 operates through a non-competitive inhibition mechanism, while BI 765423 likely functions as a competitive inhibitor. Both have promising implications for extending healthspan and lifespan by targeting the IL-11 pathway. The I765423, developed by Boehringer Ingelheim, is another IL-11 inhibitor that is structurally and functionally distinct from X203. This molecule also targets the IL-11 pathway, but it interacts differently. While specific details of its inhibitory mechanism are proprietary, the I765423 is a small molecule inhibitor, typically functioning by binding to the IL-11 receptor or interfering with the receptor-ligand interaction. In competitive inhibition, the inhibitor competes with the substrate for binding to the target's active site. This prevents the target from interacting with its substrate, in this case, IL-11 binding to its receptor. Let I equals concentration of the inhibitor BI765423. T equals concentration of the target IL-11 receptor. TS equals concentration of the target substrate complex, IL-11 bound to its receptor. TI equals concentration of the target inhibitor complex, receptor bound to BI765423. S equals concentration of the substrate, IL-11. K sub 1 and K sub negative 1, K sub 2 equals rate constants for the respective reactions. The differential equation for the reaction with competitive inhibition can be given by d over dt equals K sub 1 times T and times S minus K sub negative 1 plus K sub 2 times Ts K sub I times T and times I. And the latex code is \frac d Ts dt equals \small k underscore 1 T S K underscore dash 1 plus K underscore 2 Ts K underscore I T I. And for the target inhibitor complex, dI over dt equals K sub I times T and times K sub negative I times Ti. And the latex code is \frac d Ti dt equals \small k underscore I T I K underscore I Ti. Here, K sub I is the rate constant for inhibitor binding, and K sub negative I is the dissociation constant of the target inhibitor complex. Unlike the non-competitive case, the inhibitor directly competes with the substrate, so the formation of the target substrate complex is reduced in the presence of the inhibitor. Healthspan and lifespan implications. Both X203 and BI765423 are being explored for their potential to extend healthspan and lifespan by reducing the harmful effects of chronic inflammation and cellular senescence. By targeting IL-11, these inhibitors aim to prevent or reverse age-related tissue damage, potentially leading to longer, healthier lives. X203's non-competitive inhibition suggests a more consistent and potentially broader effect across varying biological conditions, making it a strong candidate for therapeutic applications aimed at longevity. The I765423's competitive inhibition could offer more fine-tuned control over IL-11 activity, which might be useful in cases where precise regulation of the cytokine is necessary, such as in personalized medicine approaches. Clinical development. The clinical development of IL-11 inhibitors like X203 is still in the early stages. However, the progress made so far is promising. Boehringer Ingelheim, in collaboration with Interleukin Bio, has been working on a related IL-11 inhibitor, the I765423, which has entered clinical trials. These trials are currently focused on assessing the safety and tolerability of the drug in healthy volunteers. The outcome of these trials will be crucial in determining the potential of IL-11 inhibitors for treating age-related conditions and extending lifespan in humans. Future prospects. The successful development of X203 could lead to a new class of anti-aging therapies that target the fundamental processes of aging at the molecular level. If proven effective in humans, X203 could be used to prevent or treat a range of age-related diseases, thereby improving quality of life and potentially extending human lifespan. This would mark a significant breakthrough in the field of gerontology and personalized medicine, offering new hope for tackling the challenges of aging. In this video, we've delved into the exciting world of IL-11 inhibitors, specifically X203 and BI765423. These things offer promising avenues for extending healthspan and lifespan by targeting the IL-11 pathway. As research continues to advance, we can anticipate even more groundbreaking discoveries in the field of anti-aging. Stay tuned for future updates on the progress of these inhibitors and other innovative approaches to combat aging. Next video will cover senescence because IL-11 has been shown to induce cellular senescence, a state of irreversible cell cycle arrest. By inhibiting IL-11, the accumulation of senescent cells, which contribute to aging and age-related diseases, is reduced. Don't forget to like this video if you found it informative. Subscribe for more science-based content. Leave a comment with your thoughts or questions. Thank you for watching.